Can everyone see my screen okay?
Yes.
Okay, perfect. So for those, I think I know most of you, but for those who might not know me or recognize me, my name's Jason Bomar. I'm with LA Networks. We're a gold partner headquartered right here in LA. Although we work globally, all of our engineering talent is here in LA, and then we just travel as needed. So we're kind of a local partner, a true local partner. And Robert had asked me to do this a little while ago, like maybe a month ago. He brought up maybe going over how networking is done in AWS. While I am CCIE and I mostly do enterprise networking, I suppose, although I also do some ACI and some security. The last 4 years, my largest account, most of my time has been spent doing networking in AWS. And so I do quite a bit of AWS networking, which sometimes is similar and sometimes is incredibly different. So anyway, he thought it would be a good idea to kind of cover some of the ways that networking works in AWS. And a lot of this is actually general enough that it could also apply to other clouds like Azure or GCP. The concepts, at least, the specifics of how something might work would be different cloud to cloud a lot of times. And of course, the terminology would be very different cloud to cloud. So I also should mention, I do have an AWS console that I set up over the weekend. So if at any point you have any questions on any of the slides, or you would like to see what this looks like in the console, just let me know, and I'll just switch windows over to the AWS console, and you can see what it looks like. So we can demo. I won't say we can demo any of these slides, but we can demo a lot of them. Some of them would require things like private circuits, and obviously I can't pull a private circuit at a whim. So real quick, we'll just be covering like the basic concepts, which is just a few things that you just kind of have to be aware of. And then we'll cover the basics of VPCs, VGWs, and IGWs. And then the bulk of the presentation will be on routing. And then we'll talk a little bit about circuits in AWS, and then just some final thoughts. That being said, I do a lot of other things in AWS than just these. So if you have other questions or anything specific, you can just ask. If I don't know, I'll just tell you I'm not really sure on that, or I'll give you my best guess, but let you know that's all it is a guess. Sometimes I might have some pretty specific thoughts, so based on my experiences. So the first basic concept or common concept is really the concept of a region. And this is pretty self-explanatory. It's just a geographic area that has multiple data centers within that geography. So this was the region map for AWS, I think about halfway through 2019. It's already out of date. Like down here in Johannesburg, that region is now live, I believe. I think that the Jakarta region is also live now. They spin up anywhere between 3 and 4 regions a year typically. And regions are true physical data centers. They also have a concept called edges, which we're not really going to get into, but they have a CDN or content delivery network option. And those utilize these items called edge locations. And there's a lot more edge locations, in the hundreds, as opposed to into the dozens. So, but the first concept is region. And a lot of services can be regional, meaning when you build or design a particular type of resource, like a VPC, for example, you're going to find that it's a regional construct, meaning it exists only within a certain region. And getting in and out of that region, you have to understand kind of the nuances of what it is you're trying to reach and how you would get in or out of the region. The other concept is availability zones, or AZs. I'll probably just call them AZs. Most people do. And an AZ is really just a data center. It's just a physical data center. So it could be a single building, or maybe a very closely grouped cluster of buildings, like a campus sort of thing. Every AWS region has multiple availability zones for the most part. There's a few really old regions. I think there's one in Japan, for example, that just has a single AZ, but those are really rare these days. Typically, when Amazon builds a region, they will always have a minimum of 3 AZs. Really popular regions like US East 1 and Ashburn, Virginia, has 6 AZs, for example. That's just because of the scale that they have in that particular region. So when we talk about an AZ is really just a physical data center, right? When we talk about multiple AZs, that means that they're split up over enough geographic distance to be highly redundant from one another, separate powers, separate telecommunication paths, things like that, right? So every region has multiple AZs for the most part. So if I have 3 AZs, they're going to be probably a minimum of 100 miles apart and could be probably a couple 100 miles apart. One thing that's a little confusing to people at first is this concept of AZs. What Amazon does with it to ensure that no one kind of overloads any one particular AZ is your AZs may not line up with my AZs. And what that means is if we're both up in AWS and we're going to collaborate, even though we're 2 separate organizations, I might tell you, hey, my primary resources are in availability zone A or AZA. So, you know, to get best performance, maybe you want to put your stuff in AZA as well. Or maybe say, to get the best redundancy, you might want to put your stuff in AZB. But it turns out my AZA or B or C or whatever could actually be physically different data centers than your A, B, and C. They don't line up the AZ letters between different accounts, and that's on the per account basis. They kind of randomize the AZ assignments. If you want to find out the actual AZ you're in, if you go in and look at the subnet objects, subnets are actually affiliated with a single availability zone, you'll see an AZ number. So if you go by the letter, which is what most of the AWS console refers to the availability zone as, that's randomized. And my A could be your B, or our A's could be the same, or they could be different, for example. But my AZ1 would always be your AZ1 as well. So the numbers will line up. And you can definitely find out those numbers, but they're not always obvious. You just have to dig a little deeper in the console. So those 2 concepts, we'll get into more of the networking. And those are kind of important because a lot of the resources or services that we'll be talking about might be constrained to within a region or to within an availability zone. So the fundamental unit of networking in AWS is the VPC, stands for Virtual Private Cloud. You can just think of it as your data center in AWS. It's obviously virtual because it's in AWS, but it's truly a private cloud when you first spin it up, meaning it's basically self-contained. It has no path in or out. You could build all sorts of resources in there, but if you don't build any kind of gateway connectivity in or out of the VPC, then there's no way in or out of the VPC. That might be great if you're trying to do something like a sandbox where you're doing something that might be fairly risky or fairly sensitive or something like that, or you wanted to recreate a particular environment and use overlapping IPs and DNS and everything else. You could do that and just put no gateway connectivity in there, and it would just be a kind of a self-contained data center effectively. We'll talk about the gateway options in a few slides. The VPC is a region-based construct. So a VPC by default spans all availability zones within the region, but the VPC is constrained to the region that you build it in. Azure has something similar called VNets, and they're kind of similar. Google Cloud is a little bit different in that they have something also called a VPC, and it's very similar to the AWS VPC. However, their VPCs are actually global in nature. So when you build a VPC in GCP, it actually spans the entire globe, which has some pretty unique advantages that only Google can kind of take advantage of. So we'll mostly focus on AWS, but if something like that kind of comes up, I'll try to let you know the differences between the different major cloud providers. So usually when you create an account in AWS, the first thing that happens, you don't do anything, this just happens at account creation, is that AWS will create a default VPC for you in every single region, and they will set up default subnets in that default VPC for you, again, in every single region. There's no charge for this. You don't get charged for creating VPCs or subnets, generally speaking. So they just pre-do that. It's interesting because most people choose not to use the default VPCs. You cannot nor should you ever delete a default VPC, but most people, including most Amazon professional services folks, would tell you it's a best practice not to use the default VPCs. So the reason for that is, well, I've never heard really official reasoning, but I have talked to a couple of AWS consultants, and it's very similar to, if you know Cisco ACI very well, and if you've ever worked with advanced services on an ACI install, for example, they'll tell you that in general, they don't like you ever using the default objects in ACI for the most part, because between major upgrades, behaviors could change to the default objects that would not apply to non-default objects. And I've heard this similar thing within AWS, that in general, they like you not to use the default objects, whether those be VPCs or subnets or something else, just because when AWS rolls out new features, and they roll out thousands of new features every year, I think about 4,000 last year in 2019, the concern is, especially in networking more than any other area, that fundamental behaviors might change on those default objects that would not propagate to the non-defaulted objects. So when you create a VPC, if you create one kind of fresh and new, the first thing you have to do is assign it a CIDR block. So whatever you want, it can take up to a /16 for its primary CIDR block. It can't be more general than that. You can't give it 10/8, for example. However, you can assign secondary CIDR blocks, and you can edit, modify, or well, you can add or delete a secondary CIDR block. You can never edit in any way. It's an immutable thing, the primary CIDR block. The only way to get rid of a primary or edit a primary CIDR block would be to destroy the entire VPC and recreate it. The secondary CIDR blocks can be added or deleted at will, but the primary CIDR block is immutable. Also, in every VPC, there's something known as the intrinsic router. Some people also call this the VPC router. AWS actually officially calls it the intrinsic router, though. And its basic purpose is to route between all the different subnets within your AZ. So you set up your CIDR block, and then from within the CIDR block, you're going to create individual subnets that might span, well, will have to span against different availability zones. And the way that you route between those availability zones is through the intrinsic router. There's other things as well. There's DHCP and DNS services that get affiliated with the intrinsic router. You do have the ability to interact with the intrinsic router, but only minimally. So you can, for example, you can view or edit its route table, but you would never want to treat it like a normal router. When we think of, as Cisco engineers, when we think of routers, this intrinsic router is not one of those routers. It's very basic. There's also a few things you can't do. The CIDR blocks that are affiliated with your VPC, they're auto-tagged into the routing table, and they can never be removed from the routing table. So every CIDR block you add, if you have a single CIDR block, you'll have one route. It'll be listed as local, just like it might on a Cisco router. If you have a secondary CIDR block, you'd have two that would say local. You cannot change that behavior. You could change the propagation outside of the intrinsic router, but you cannot remove a CIDR block from the intrinsic router. And you can add static routes into the intrinsic router. And that mostly looks like on a Cisco router, right? You'll put in, your destination network with the mask and a next hop. The only thing that's kind of unique is the next hop itself. Normally, we would think of a next hop as an IP address, and you can absolutely put that in. However, you can have all sorts of AWS objects that are next hops as well. So it could be a endpoint. You could make your next hop be a what they call an ENI. We'll talk about those a little bit later. All sorts of things. So a few things on the VPC. After you create the VPC, which again forces you to create a CIDR, there's two additional objects you're going to want to create. The first one is subnets. You have to create at least one subnet, but almost always you would want to create multiple subnets. A lot of people create one subnet per availability zone. A better practice would be creating one subnet per AZ that you intend to use, right? So keep in mind that an AZ is affiliated with a subnet. It's a layer 3 boundary. And all of AWS's SLAs for things like EC2s, which are their basic VMs, are basically predicated on the concept of AZ redundancy. I can't remember what the SLA is if you put an EC2 or a service into a single AZ. It's maybe like 99% or 99.5%, but it's not that high. However, if you break that service up across multiple AZs, depending on the service and the AZs in the region and so forth, you can get much higher SLAs. So probably the highest SLA that AWS has is their S3, which is a storage service, which we won't cover today. We're going to cover storage, but they're pretty proud of the fact that S3, when you fully enable all the redundancy features, has 11 nines of reliability. So usually splitting your subnets across multiple AZs is very typical and best practice. Also, AWS best practices, like if you actually work with AWS consultants, they will tell you to tier your subnets and then set up some kind of security boundary between those different tiers. You could kind of think of this as app-centric ACI. That analogy will break down very quickly. It's not really like app-centric ACI, but it has some high-level common constructs. So I will also tell you, just like app-centric ACI, most of my clients, they like this concept, and then they don't ever adhere to it. So they immediately go back to something that's a little more network-centric, just like almost all my clients who have done ACI have done the same thing. They start with this idea of, well, app-centric sounds amazing, and then they realize no one knows how these apps communicate, and they have no good path forward. And so they fall back to network-centric. I would say I find that more often also in AWS, but they don't really have a network-centric. So the way it looks in AWS would be a little bit different than in ACI. So again, that analogy will break down. The other thing you're going to want to create typically are at least one routing table. You could also create multiple routing tables. A little bit later on, we'll go through why you might want multiple routing tables. So there is a default routing table. Again, AWS usually recommends you don't use the default routing table, but to create a custom routing table. That routing table is effectively for the intrinsic router. So beware of any intrinsic router limitations. When I talk about intrinsic router limitations, I mean that the intrinsic router, again, it's static routes only. It doesn't do any dynamic routing. Also, probably the largest limitation on that intrinsic router, it only can have a maximum of 100 routes, which just sounds kind of preposterous to a Cisco engineer to be limited to 100 routes. You can't ever remove the static routes or the local, I should say the local routes from the routing table, for example. So there are limitations with these routing tables. And again, if your basic connectivity is fairly simplistic, you just do probably a single routing table for the entire VPC. We'll go through a use case with if you wanted to put, like, say, a virtual FTD or ASA or something like that and route all traffic through that virtual appliance. A little bit later, we'll talk about that. That uses a more advanced feature, and we would do multiple routing tables for that instance. This is kind of what the VPC subnet tiers would kind of look like, right? And like I said, it's a little bit similar to app-centric mode in ACI, but you can see the user would come into the front-end tier. The front-end tier would come into the app tier. The app tier would come into the data tier. As I kind of mentioned, the analogy breaks down kind of quickly. We're not going to go into security groups unless someone really wants to go into security groups, but the security groups are very different from, say, ACI EPGs. They're not really very analogous at all. And so the way that you would set up these tiers and do the access itself would be very different than what you would do at ACI. But if you've ever done an ACI deployment, this would look pretty similar to you. So let's talk about gateway connectivity. The first one we'll talk about is the VGW, which stands for Private Virtual Gateway. I don't know why Private Virtual Gateway, the acronym is VGW instead of PVG, but it is. This is basically the routing service that you would use to connect to your CPE. So, you know, your FTD firewall or your ASR router or whatever. But so I'm not using this to connect to, say, the internet. I'm using this to connect back to my on-prem. I can do that either via VPN or dedicated circuit. We'll go through some of the caveats at the end of the presentation on dedicated circuits. AWS refers to any routing device that they do not administer but are connected to at a layer 3 standpoint as a customer gateway or CGW. So, you know, pretty much always the VGW will always connect to a CGW. That's only important because when you start building out these connections and so forth, Amazon's always going to say, you know, things like, oh, you want to paste the following in your CGW. Oh, you want to verify the following capabilities on your CGW. I just want you to be aware of what a CGW is. The CGW would be your ASA, or it would be your ASR or ISR or whatever you're terminating that connection on, right? The CGW is just your CPE or customer on-prem.
Jason, a quick question on that. So you'd mentioned Amazon can sometimes administer or tell you to do an upgrade on your CGW for whatever reason. Do you often see customers have separate VRFs on their whatever on-premise CGW they have connecting to the VPC or connecting to AWS or even dedicated routers for that matter? Or does it matter?
Yeah. It can. I think that was Sava, and that's actually an excellent question, and it brings up. Actually, let me back up 2 slides. I should have mentioned on these routing tables here. Even if you have multiple routing tables, do not think of these as VRFs. Normally, as a Cisco person, when you think of multiple routing tables on a single router, you would think of VRFs. These are definitely not VRFs. We do multiple routing tables in AWS. But to answer your question, Sava, I've seen it both ways. I would say my larger enterprise sort of accounts, they like to do this on VRFs, either on dedicated gear or not, but they like to put any kind of third-party routing adjacency into its own unique VRF. I would say on my more select or mid-sized tiers that do AWS, they don't do that. They're usually leveraging AWS in a fairly different way than my enterprise accounts are. I don't know, if I'm just being honest, this is just purely opinion. I don't know that there's a huge advantage to VRFs or dedicated hardware, but you know, the one exception would be if you're going to order things like private circuits, which again we'll get to at the end, and you were going to do like say 10 gig circuits up to AWS, you might want dedicated gear just from the throughput standpoint, right? The VRFs become a little more critical if you're going to do, and we'll talk about this on the circuits, but it wouldn't apply to VPN per se, but on circuits, we have this ability to do sub-interfaces on your circuits to break them out into virtual kind of pseudo-wire circuits, and they could be public or private. And in that case, you absolutely want different VRFs. So for example, if I'm using a public, what they call virtual interface or VIF, if I'm using a public VIF, I definitely want that public traffic to go into its own VRF that would come down to like a FTD or something like that. The private traffic, you might want to just think of that as just private traffic. It might just be your, like connecting to any other office in your network, right? And really, ultimately, it kind of comes down to what they're using AWS for and what their architecture looks like. Are they allowing internet to go directly in and out of their VPC? Because if so, then separate gear and separate VRF starts to make a lot more sense. Or are you tunneling all the internet traffic back to your on-prem where it's already going to get inspected by a firewall and your umbrella, get protected by your umbrella subscription and so forth? Because if so, then maybe the separate gear doesn't make a lot of sense. And again, unless you have a performance requirement or something like that. Did I answer your question, Saba?
Yeah, it did. No, I appreciate it. It makes sense.
I mean, yeah. Okay. So if you're choosing the VPN route to connect to that VGW, which is very common, they will actually build the VPN configuration for you based on your gear. You create this thing called the VGW. And when you do, it will actually walk you through a wizard and will say, what are you going to connect your, what's your CGW look like? Is it a Cisco ASA? Is it a Cisco FTD? Is it a FortiGate firewall? I don't know if those even exist, but someone told me about them once, but is it going to an ISR? Is it going to an ASR? It'll ask all these questions. It'll even ask you, okay, if you're going to an ASR, what kind of code are you running? Are you running 3.6? Are you running something else? And then it will actually give you a text format that you can download that's fully commented and everything. And I will tell you that the configs that they give you are actually quite good. They will require a little bit of tweaking, and they're fully commented. So it'll even tell you things like, you may not need to enter this if you have the following enabled, or it might say you need to enable the following only if you're going to do X, Y, and Z. So they're pretty good about being context sensitive. So those pre-built configs work. You may need to tweak them a little bit, but overall they work pretty well. I'm also going to point out that the VGW is one of the oldest networking constructs within Amazon. And as such, it's pretty outdated. So when I say outdated, they only started supporting IKE v2 like about a year ago, right? And IKE v2's been out forever. They had very poor hashing support and encryption support. They didn't support AES for the longest time. I think last year, 2019, or it might have been 2018, I can't remember, but one of them, the VGW, finally got a facelift. And when they did, some of the IPsec standards kind of came up at least a little bit. They're fairly inflexible, so that's why they build those templates for you. There's not a lot of negotiating. Normally, IPsec, there's at least some negotiating. Of course, negotiating in IPsec is infamous for only working well between a vendor, not in between vendors, and it's no different here. None of the negotiations work very well. When they give you that configuration, you're kind of stuck with that configuration. If you do those VPNs, AWS is famous for incredibly aggressive timeout values. When I say incredibly aggressive, it used to tear down the tunnels after 3 minutes of idle. It's gotten better than 3 minutes. They just couldn't keep that up at scale. But it's still really aggressive timeouts, like 15 minutes of no interesting traffic, it'll tear down the tunnel. So you might want to use something like IPSLA or even better, you can run dynamic routing to a VGW. It supports BGP. So if you do BGP, for example, you could do it with that as well. If you order direct circuits, they're called direct connects. We'll talk about those at the end. Then you don't have that timeout issue at all. Also, data in to AWS is free. Not surprising. You can put as much data as you want in. Data coming out of AWS, you get charged for, right? If you buy dedicated circuits, the direct connect circuits, you still pay for data out, but the data out goes down by like a factor of 10, or I think it's even higher than 10. The data out charges go down dramatically once you buy direct circuits. So, as I mentioned, the VGW does support BGP and static, but it's super simplified BGP. Don't expect to be running BFD to this thing. You can't do any route filtering. By the way, you cannot, by default, you cannot even look at the route table on the VGW. There is a way to get your routes on the VGW to propagate to your intrinsic router. And you can see them there. And all the routes on your VGW count against that 100 route limit I mentioned earlier on the intrinsic router. That caused probably the largest ever outage I had for a client in AWS, was going above that 100 route limit. It's kind of a longer story. It's in my Cisco Live talk I did a couple years ago, but it was a pretty nasty outage. So yeah, you want to be careful of that 100 route limit I mentioned earlier. This is what the VGW looks like. You basically build out your VPC, you set up your site, or you set up your subnets. You create this thing called a VGW, Private Virtual Gateway, and it will build 2 tunnels. So the VGW is always highly resilient. It's split across the AZs, so any outage in a particular AZ will not impact your VGW, because the VGW is effectively a cluster of VC2s under the hood, and just one of the other AZs will pick up the function. And so they assume that you will be highly resilient on your end somehow. And so they will always build or expect 2 tunnels. You don't have to build them both. You could build a single one. It looks a little weird when you do that, because one of the tunnels will always show down in the VGW, but it's kind of more of a cosmetic thing. So, and again, remember, the VGW is for your on-prem traffic. It's always coming back to your customer gateway. So the other option is the IGW, or Internet Gateway. The IGW does for public communications what the VGW does for private communications. So the IGW connects you directly to the AWS Internet Backbone. One thing is that it's not a layer 3 gateway in the sense of you cannot put routes on an IGW. It's just there as truly your gateway to the Amazon Internet Backbone. The AWS Backbone, and I should say this, when I say Internet Backbone, I really mean the AWS Backbone. The AWS Backbone is a public backbone. It's all public addressing. You will need some form of net to traverse the public backbone on AWS. But it doesn't, you know, it is an AWS backbone until you hop off of AWS.
Hey, Jason?
So, you know, if you go to Google, for example, it's,
hey,
yeah,
Jason?
go ahead.
You may want to shut off your video. It's if you're coming in over the internet for your voice, it's a little bit, it cuts in and out.
Oh, okay, 1 second.
Yeah, just FYI. I don't know if that'll help, but hopefully.
On my end, it sounds great. I don't know if anybody experienced that, but it was good on my end, Robert.
Yeah, mine was really choppy as well. I was catching every like 5th word.
Yeah, it was choppy for me.
Okay, can you hear me better now? I turned off the video.
Yep, definitely.
Can you guys hear me any better?
A lot better, yeah.
Okay, no problem.
Yeah.
Thanks for the feedback. Do you want me to go back over the IGW stuff? Is that where I started getting really bad?
Sava, do we need to?
We can go over this really fast.
Yeah, just maybe really fast, yeah.
The IGW just does for communications publicly what the VGW does privately. It's how you get on to Amazon's AWS Internet Backbone. So it does require some kind of NAT. It's a public backbone. The other thing is to be aware, anytime you want to go between regions or even between services that you own in your VPC and services even in the same region outside your VPC, you have to go across the AWS backbone, which again is a public backbone. So you'll need the IGW for items like that as well. So it's effectively your internet connection. It does not do any routing in terms of you cannot put routes on it. You can just send a default route out the IGW. If you want to do internet routing, you will have to have some other type of device. This just provides you the connectivity to the internet. It has effectively infinite bandwidth for all intents and purposes, as opposed to the VGW, which has very limited bandwidth, 1.25 gigabits per second. The IGW goes up over 50 gigs per second. So you can pretty much eat as much internet as you want through an IGW, but you do get charged for that. So you probably wouldn't want to do 100 gigs. The bill would probably get ridiculous. And this is just what it looks like. Again, you need some form of NAT. I'm not going to cover NAT in this one. There's two main ways to do NAT. You could do it with something called an elastic IP, or you could do something with a NAT gateway. Or of course, you can put a third-party product in there like an FTD and do the NATs on the FTD, for example, or the ASA, right? But you would need the NAT to go out the IGW.
Hey, Jason, if we put like an FTD there, does it take the place of the IGW, or does it run in serial to the IGW?
It runs in serial. You can never replace any of the Amazon objects, really.
Okay.
But keep in mind that the IGW, it's more of a routing service. It's not a router. You can't run BGP on it. You can't even put static routes on it. It's really just a layer 3 gateway to get to the AWS public backbone. It's a bandwidth provider, a layer 3 bandwidth provider. So you would need something in the VPC that routes to the IGW. You could do that with the intrinsic router. You could just put a default route that says, hey, default route, point to my IGW. Again, when you do a static route on the intrinsic router, you can point to things other than an IP address. You can point to objects. And you could say, my next hop is the IGW. If you do that, of course, you have no security whatsoever. So I don't think I'd recommend it, but you could. But if you put an FTD in there, you would just basically tell the FTD that its next hop would be the IGW. And you'd have to figure out how you're going to do that. And I'll go through that towards the end. We'll talk about something called VPC ingress routing. So a quick word on routing in general. I mentioned this just a second ago. These are not really routers the way that we might think of routers. You want to really think of these as routing services, meaning they're just EC2 clusters that have some kind of routing capabilities turned on. You can't log into these and do a show IP route, or they only route static or sometimes static and BGP. There's no other options. There's no way to do any advanced filtering at all. There's no way to do any filtering, period, full stop. They're very limited in their capabilities. We'll get into another construct in a minute that has a little bit better. However, because there are just effectively clusters of VMs, they do have high resiliency built right in. They're always spanning all AZs within the region. So it doesn't matter what AZ outage might be occurring in AWS. I'm not saying AZ outages are common, but if you only have 99% uptime in any given AZ, they're not uncommon either, right? So, but it's invisible to you because the failover is in the micro or millisecond range. They're very fast, and so it just goes right over to another one, and you don't see it because to you it's just an IGW or just a VGW, so you don't even notice that there was any outage at all. So they do have the VGW in particular poor support, right? 100 routes maximum on the intrinsic router. And remember, your VGW routes count against that 100 route limit. So if I'm running BGP to that VGW, I sure don't want to. I don't want to reflect my entire routing table up there. I probably just want to send a summary route or a default route or something like that, because any company can run through 100 routes pretty damn quick. And then the VGW, it's capped at 1.25 gigs, and it does not support ECMP. So remember, I said it builds always 2 tunnels minimum. Those tunnels are active and passive. It will send all traffic down a single tunnel until that tunnel is not available. Then it will fail all traffic over to the other tunnel. There is no ECMP on the VGW. So some challenges in routing up in AWS. The first one is they don't support transitive routing natively, or didn't. This has changed a little bit recently. I did a whole talk at Cisco Live a couple years ago on this. So we would normally think that if A can pair with B and B can pair with C, then A can route to C just fine. It just route through B. In AWS, that doesn't work. If I have a VPC here that connects to this VPC, and that VPC connects to this VPC, I can get my routes to propagate just fine, by the way. However, when my packet hits B going towards C, it gets dropped here. The VPCs have a security mechanism kind of built in that basically says if the destination is not within my VPC, then I will drop the packet. And that, it's just transitive routing, which we would take for granted, and it's more or less impossible. There were some really clunky workarounds in the early days with this thing called VPC peering, but it does not work well. It's not very scalable. It comes with a lot of limitations. So AWS actually worked with Cisco on something called the Transit VPC, which solved this. And what this is you spin up a pair of CSRs into a specific VPC called the Transit VPC, and then we tunnel our traffic, right? So we just tunnel our traffic from this spoke all the way down onto the CSR. Of course, the CSR can hold plenty of routes, and it has no problem transitive routing. And every spoke tunnels its traffic through a GRE down onto the CSR. And then the CSR can route between them because it doesn't have the same limitation. It gets a little weird because remember I mentioned that the VGW to every CGW builds 2 tunnels. And of course, to make this highly reliable, I have to put 2 CSRs in every VPC in different AZs. So I end up getting 4 tunnels, all non-load shared. There's no ECMP on the VGW, but I have to build out 4 tunnels to connect 1 client VPC. And I'm limited to that 1.25 gigs at the spoke side, but the CSR itself has a 4.5 gig theoretical limit. I say theoretical because I've never actually seen one get all the way to 4.5. So there are still limitations with this, but this is a lot better than anything else. And AWS actually worked with Cisco. They came up with a automated way to do this through scripting. My largest client, we've been running that scripted solution for over 2 years now. It works really well. When you spin up that spoke VPC, you just put a little tag field in there, and it pre-builds the tunnels, the GREs, sets up the BGP. It does everything for you automatically. No engineering really required for the most part. So, and it takes maybe 1 to 2 minutes, I would say, typically. And then you can just start building out all your stuff in the VPC, and it's completely reachable from anywhere else in Amazon or on-prem. So it worked out pretty well. It did come, though, with some limitations. You're still limited to the 100 routes up on those spoke VPCs. The CSR, of course, can handle a lot more routes, depends on what they call the instance type that you run, but it can handle up to 4 million routes if you have a big enough instance. The problem is that script that AWS and Cisco worked on several years back, it reflects all routes by default. So once you get to somewhere a little bit south of 100 spoke VPCs, now you've got a problem because you'll break that 100 route limit barrier. So there's some ways around that. We won't go into it. It's a little bit detailed. You're limited on the CSR throughput of 4.5 gigs. And it's very inefficient on the traffic because, again, there's no ECMP, right? So I have 4 tunnels, 3 of which are just sitting there idle, and only 1 of which has any traffic going through it. Why would you spin up all the spoke VPCs? Well, there's 2 big ones, and that is to break out the billing. This is really nice because now a company can say, hey, any business unit I have or any group or any project I have, they can just go spin up their own VPC, and I can bill them for what they consume in AWS. And it's very easy, very simple. This is a package solution that AWS just kind of provides. The other one is blast radius. And by that, I mean, since I do 1 VPC per business initiative, let's call it, or project or whatever, that means that I never have to worry about one business unit impacting the resources of another business unit. In the old days, before they had this kind of transit VPC, this was a common problem because everyone needed access to the AWS console, and while you could get granular with the permissions, a lot of people just weren't doing that, and all of a sudden you could say, oh, I need to delete these EC2s because I'm done using them and I don't want to pay for them anymore. And if you're not careful, you accidentally delete someone else's EC2s. So when you spin up these separate VPCs, your blast radius, the only person you can hurt is effectively yourself. So there's something now that is called a shared VPC. We're not going to go into necessarily, but that kind of addresses both of these, and I don't have to have a lot of spoke VPCs. But the shared VPC is a little outside of what I was going to go through. So in 2018, AWS released something called the Transit Gateway, or TGW. This effectively killed the Transit VPC. So there are still lots of Transit VPCs out there, but I don't think there's any account that isn't looking at trying to get away from their Transit VPC and move over to the TGW. It's less cost and way more scalable. I have 50 gig of throughput. That's minimum according to AWS. They said basically the fastest traffic generator they could really get in the cloud was 50 gigs, and so they said it's 50 gigs. But they say, you know, theoretically there's no reason that they couldn't scale that up to 100 gig or more. You can get 5,000 routes on your TGW instead of that 100 routes. That's a soft limit. You can go up to 10K as a hard limit, but you know, no matter what, that's way better than the 100 route limit that you had before. It attaches to a subnet object and supports ECMP, so it's just a lot more efficient in terms of network utilization. And it also supports not just direct attachment to the subnets, but it also does support VPN attachment with BGP support. So this is what the TGW looks like, and you can just see it basically attaches into the different AZs. You're still limited to 1.25 gigs for each of these attachments. However, now that I can ECMP, I could get, say, you know, across 4 attachments, I could get 6 gigs of traffic, which is a lot better. I can also double up these attachments. I could scale my attachment up to 50 gigs, which is the limit of the TGW if I wanted to. That would probably be ridiculous, but, you know, it just simplified a lot. You went from that 4-tunnel, a lot of overlay networking to this kind of simplified all AWS. So the big takeaway here is you need to be aware that the transit VPC is effectively a dead technology. This is a little concerning because still most of Cisco's literature and solutions are really centered around that transit VPC. And I don't know how much you talk to people who are doing a lot of AWS network architectures, but no one's very interested in keeping that transit VPC around. It's more expensive for a lot less features and scalability. If you did put that virtual FTD or ASA or whatever up in there, There used to be a real challenge in how to route all the traffic through the network appliance. That was solved last year in 2019 with something called ingress routing, or VPC ingress routing. And this is when you would build out different route tables into your VPC. You basically need one route table per zone that you're going to have separated. So here in this example, I basically said I've got an untrusted zone that's going up to the internet. I've got a DMZ zone, and I have a trusted zone, like an inside. So like an in, out, and a DMZ, right? And that would mean that I have 3 route tables, one per each of those zones. I also have a 4th routing table that is effectively tied to this IGW. This is important because there's an order of operations in Amazon that the intrinsic router always takes precedence over anything else. And so they added a new type of routing table called an ingress routing table. In the order of operations comes before the intrinsic router. And so this allows you to override the intrinsic router. That's important because if you recall, the intrinsic router keeps local all the CIDRs in the VPC. So that means my DMZ to my trusted communication, it would never go through my firewall. It would just go from DMZ to subnet because it would hit the intrinsic router before it hits my appliance. Same thing for all the traffic that was coming into the VPC. It would bypass your appliance and it would go just straight to the subnet, and that would obviously be terrible. So, so they introduced this feature called, you could do this before, it was just very complicated how you did it. With the intrinsic, or with the ingress routing, it's become very simple. You do have to create these things called ENIs, which are just like VNICs. You could just think of an ENI as a VNIC. It stands for Elastic Network Interface. It's a dedicated VNIC for your VM, effectively. And on these routing tables, you can just set the next hop to be the ENI of the appliance. And with the ingress routing feature turned on, this will take precedence over the intrinsic router. And so you can override that default behavior that used to cause so many problems. So it's just a way to tweak the order of operations within the VPC effectively. And like I said, this was surprisingly difficult to do before that. You had to jump through all sorts of unnatural hoops. Anyone have any questions on this? Real quick on circuits. So you can order private circuits called direct connects or DXs. These are typically always run to a colo provider. Equinix is by far their biggest partner, but not their only partner. Anyone who's familiar with the Switch data center in Las Vegas, for example, you can buy direct connect services there up to, say, Oregon. But Equinix partnered with AWS effectively really early. They built out physical data centers in all the AWS regions as close as they could get to the AWS data center, and so they tend to have very good performance. They're frankly not the best data centers. I like the Switch data center to me is a lot nicer than an Equinix data center, but when it comes to the AWS connectivity, you really can't beat Equinix. Other providers may have third-party product offerings where they could tie it directly to your network. AT&T, for example, has something like this, where you can basically tie the AWS into like your MPLS network. Obviously, it has to be an AT&T MPLS network, an AVPN network is what they would call it. And the way that it actually works under the hood is they're just set up a giant colo in an Equinix facility or something like that. May not be Equinix, but a colo. And then they are just bridging between the AWS Direct Connect handoff and their AVPN network and bringing it in on your VRF effectively. Those third-party product offerings I have a lot less familiarity with. I know a little bit about the AT&T one because I did have to research that for a client. All these DXs or direct connects, they will require these things called VIFs or virtual interfaces. There's 3 types of VIFs, public, private, and transit. The transit is specific to that transit gateway object we talked about that replaced the transit VPC. If you want to tie your direct connect service up to a TGW, you need to do it through a transit VIF. Public and private are pretty self-explanatory. Private just means my private cloud that I'm attaching to does not go through an IGW, it goes through a VGW. My public would actually go through an IGW. And so the couple things to keep in mind, to enable direct connects, you will have to enable BGP. So the customer needs the ability to run BGP on their CPE that's going to terminate those direct connect circuits. We had a run-in with this not too long ago where they wanted to terminate it on some Nexus 5K switches that didn't have layer 3 enabled. So we had to explain to them, like, no, you're going to have to put this on something that can do BGP. And they were like, well, can't we just do static routing? And it's like, no, direct connect will require BGP. If you're going to use the public VIF, you're also going to need public IP space. They used to also require you to have a public ASN registered with IANA. I think that they've relaxed that requirement. You could use a private one now, but you still need public IP space. You could use some kind of NAT space. It doesn't need to be like a /24 or anything. Most people are using these public VIFs not to get to and from the internet per se, but to get to and from public services on the AWS backbone, the number one of those being S3, which again is a storage service. A lot of websites you go to these days are actually just S3 static websites, and their public space they're just getting for free from AWS. For free, I mean it's really just baked into their S3 costs. But S3 is a public service no matter what. There is no such thing as private S3. That's maybe a little bit of a misstatement, but it's complicated. So most people are using that public service not to go to and from the internet per se, but to go to and from public services on the AWS backbone. There's also something called the Direct Connect Gateway. This allows you to buy, say 2 Direct Connect circuits, just into one data center, for example. So let's say this is an Equinix facility. These are my ASRs. And I have AWS resources in Oregon, which is called US West 2. They have AWS resources in Silicon Valley, which is called US West 1. And I don't want to buy circuits in every single region because that would get expensive. I can set up something called a Direct Connect Gateway, and I can tie that Direct Connect Gateway to multiple regions. I can't recall, but I think you can tie it up to 10 regions. And then I can utilize my Direct Connect circuits within that specific region. So maybe this Direct Connect Gateway is up in Oregon, and I could tie my Northern California circuit up to Oregon. Now, of course, there'll be some latency that's affiliated with that, but it's still a lot cheaper than pulling private circuits and building out dedicated routers in every single region. And the handoff to you is just sub-interfaces via VLAN, so it's just a 802.1q trunk. You can also make these public and private, so you can sub-interface public and private. And Sava, getting back to your question, this is when you would do VRFs probably. You would definitely want a different VRF for your public virtual interface versus your private virtual interface. You wouldn't want those all in your global routing table, especially the public one. Your private one you might want in your global routing table, but your public you would want to definitely put through some kind of firewall or security layer. Just recall that BGP is going to be required for all your peering on these. And there's a few tricks that come along with the DXGW configuration, nothing horrific, but you're going to run iBGP. You don't know that you don't do this yourself, but just so you're aware, under the hood, there's basically an iBGP relationship between these virtual interfaces and this Direct Connect Gateway service, and then it's eBGP between the Direct Connect Gateway and these VGWs, or a TGW if you were going to do that. So just be aware of those things when you're doing the circuits. This is just the kind of final thought. So remember that when you need to connect the resources in AWS outside your VPC, a lot of times you have to hit that AWS backbone, and that means that you need an IGW and some NAT mechanism. You really want to have your customers really carefully consider how their applications are going to do HA, because they're really going to probably want to deploy things in multiple availability zones, and that means a layer 3 separation. Remember, those AZs are actually physical data centers separated usually by about 100 miles or more. Keep in mind that while IGWs and VGWs look like routers, they're not really routers. They're more like routing services. Think a Linux box with some routing turned on. They come with a lot of limitations. You need to really be aware of scalability limits in AWS. We didn't really get into this much except for that 100 route scalability limit and the 1.25 gigabit scalability limit. Scalability limits in general in AWS they can be pretty brutal sometimes. And so it's important in general to just be aware of what scalability limits you might have. A word on cost, and when I talk to people about AWS in general, I warn them. I hear this conflicting viewpoint all the time. Some people say AWS or cloud computing is so much cheaper than on-prem. Or I hear people say, it's just so expensive to go into a cloud. And you would wonder, how can you have two just completely opposed opinions? The truth of the matter is, it's really a complicated question as to what's more expensive. It's not a simple like, oh, I'll just pretend that my whole Equinix data center is going to close and I'm going to do a 1-for-1 lift and shift into the cloud. If you do it, it will be way more expensive, right? But in general, the way to get the savings in cloud is to take a cloud-friendly approach to application development. And that means CI/CD pipelines and DevOps, basically. The more you can leverage infrastructure as code, the cheaper your cloud experience is going to be. And then some things like development can be a lot cheaper and a lot faster in the cloud. Prod, you'll find, might be, even if you have a CI/CD pipeline, may be more expensive in the cloud. You might get some soft dollar savings that come back, but the hard dollar will probably be more expensive, at least in the long run. So, and that's really it. Were there any follow-up questions? I know we're a little bit over time. We started a little bit late, and but if there's any questions, I'm happy to stay on.
So one question. Sorry, go ahead, Robert.
Okay.
So you referenced the AWS Internet Backbone for the public-facing IPs and all that. Is that CloudFront? Is that Amazon's like CDN network that you talked about in the very beginning? Or is that separate? Okay.
It's separate. Yeah. The CDN network, the CloudFront, it does also utilize that AWS backbone. The AWS backbone, by the way, is massive. They add, I have a friend who used to be on the backbone team for AWS. They add roughly 100 terabits per second of capacity per month. Not globally, not everywhere, but in the regions that most need it. So those IGWs, when I say that they have more or less close to infinite bandwidth for all intents and purposes, they do. Your money runs out before their bandwidth does. But the CloudFront utilizes that backbone, but it's definitely a very different service offering than the IGW itself. We could talk about CloudFront at some point if you want. It is a CDN network, similar to something like Akamai or something like that, right? There's hundreds of CloudFront locations, and the most normal utilization of that would just be like an Akamai service, which is, I know that, for example, most of my clients are, say, in North America, so I put most of my stuff in US East 1. but I just opened up in EMEA and I don't want to put a whole new cloud facility over in Frankfurt or whatever. So instead, you might just use multiple CloudFront edge locations over in Europe to stage your static content.
Yeah. Okay.
Any other questions?
Hey, Jason, I know this is a lot of information, actually, like to pack in an hour. I want to give the team a little bit of time to digest this, and if they come up with enough questions, maybe we could put together a second session and maybe answer a few more things. What do you think?
Yeah, I'd be happy to. This is a lot. Believe it or not, I cut this down quite a bit. When I do this topic at SCUG, we usually go for 2 hours.
Yeah.
So I cut out all the SCUG stuff and I kind of built this one from the ground up just to cover networking.
Yeah.
Just like with anything else, like if you were trying to teach SD-WAN or you're trying to teach ACI, an hour, all you can really do is just barely touch on these. Yeah. So there's a lot more that we just left out than we put in, and it still went a little long. Sorry about that.
I mean, I think as a part two, I would potentially like to see, like, hey, where do our, within a bigger diagram, so to speak, right? Like, where do our, CSRs fit? Where do our FTDs fit? Where do our kind of solutions fit? That would help us.
Yeah.
Positioning these, because I certainly couldn't answer that.
Yeah.
Not right now, but maybe we'll think about that. We can talk about that more later.
Yeah, I will tell you this. That's a whole topic, like where the different things would fit, because it really depends on what you're putting up there. CSR is a little bit different than, say, FTDs or ASAs. The biggest thing I could give you for feedback in general, though, is it would be very helpful if, I don't know if any of you have any push with the BUs, but Cisco is so far behind all of their competitors when it comes to cloud in general, not just AWS, in terms of what they call instance support. So that's basically the VMs, the instances. This is, again, a gross overview, but they're basically the different sizes of VMs, and all your competitors support way more instances than Cisco does, and that causes a real problem because the cloud vendors punish clients for utilizing older instances because they just want to retire those things, right?
Yeah.
So, for example, the VASA, you pay a penalty to even buy that because the instance support is so minimal. You get A, port performance, and B, you pay Amazon more for port performance than you would for good performance. So if you have any way to feed that back, I beat that drum on almost every call I'm on these days. So security and SD-WAN are the two worst ones.
Yeah, I would say, I mean, that's definitely, we can find a way to feed that back. I would need to get that like in some type of format where it's easily understandable. But I'm gonna pause here. I'm gonna stop the recording. I do want to give the team here a break.